This is Solve It for Kids.
Hello, my amazing and curious friends. My name is Jennifer, the Dean of all things STEM and STEAM, and this is Solve It for Kids, the podcast that gives kids and families a peek inside the real world of scientists, engineers, and experts as they solve problems in their jobs using creativity, cooperation, and critical thinking. And now please welcome to the show my podcast partner, Galactic Space Geek, Jeff Gagne.
Hello, Jennifer, and hello, listeners. I love when we get to talk about big issues, and today we're talking to somebody who is talking about something that is critical for all life as we know it.
Yes, I completely agree. What problem are we solving today?
How does drinking water get to your house?
How does drinking water get to your house? This is, pretty important, and this is going to be an engineering episode. Yay, I am so excited. Who is our guest today, Jeff?
Our guest today is the one and only Charles Trip Barton. He is a civil engineer with a large American water company.
Welcome to the show, Trip.
Hey, good morning, guys. Great to be here.
Well, we are thrilled to have you, and we're going to talk all about water and how it gets to your house. Kind of important topic, don't you think?
I agree wholeheartedly.
So I like to start out the show with, when you were a kid, were you always fascinated by water and how it moved?
So it's a pretty boring story. I'm the third civil engineer in a row in our family. I wanted to strike out and do radio and TV, but I got pulled back into the engineering. Now, my grandpa was a civil engineer for the Army. My dad was a civil engineer for the Illinois Department of Transportation. And then in a private practice at a consulting firm. So it was good. But no, I wanted to do something sciencey. Oceanography was on the radar for a while, but then civil engineering is pretty broad. It can cover anything.
It is
pretty much anywhere. So it's a nice general thing to do. So
and there aren't too many oceans in Illinois where you live. So
oddly enough, University of Illinois has an oceanography program, but they do, but I don't know what they do. So
So I have always kind of wondered, civil engineering, I think, is one of those areas of engineering where a lot of folks in the general public don't know as much about how many different avenues you can go down. What are some of the avenues, and how did you end up targeting water?
So it's a long story, but civil engineering is basically the engineering that all the other disciplines do not want to do. And generally, so it's roads, bridges, the structural part of buildings is civil engineering.
Okay.
Railroads, anything outside, parks, developments, but a lot of utility stuff. So on the water and then wastewater side, so clean water coming to your house, and then water going away from your house, that's civil engineering as well. We help out on the electrical and gas grids as well for layout and networks and things like that. So I started out kind of doing the transportation thing for a while. I used to do traffic signals. And then we had a couple projects that came through that were more environmental engineering. So it's more water and wastewater, that kind of thing. And that's kind of how I got in. So after I got into the workforce, that's when I kind of switched over to water. I got interested in geographic information systems. So like smart mapping, think like Google Maps for utilities, sort of. And then that's kind of where I really got into it. And then that's kind of where it progressed from there. So it's been pretty interesting. There's a lot of different avenues to get into with civil engineering. So I highly recommend it to anybody that's interested.
I mean, that sounds fun. Okay, so now I'm curious. Google Maps, you said, for kind of... So what did you say for that? Like how you use
Google Maps for utilities.
Utilities.
Anything, So basically, it's smart mapping. It's like for utilities, it's more like I have a water main leak here.
Okay.
What valves do I need to shut to isolate that leak? Who do I need to call? So it's basically all integrated now. So we can shut the valves on the map and then know, okay, we're going to affect these 15 customers.
No kidding.
Yeah, it's all pretty much interconnected, which is pretty cool. So water systems have been around probably since forever, but this
Right.
Which is a good thing, right? Which is a good
Right.
thing.
But there's new stuff that comes, new technologies that can be applied to old technologies. So that's one of the things that kind of excited me on the GIS end of things. So yeah, it's
Wow.
trace routing for sanitary sewers. And I'm just talking very small, on the
Right.
transportation side of thing. The guts behind Google Maps, center line driven, location based. The same thing is used for like transportation centers and
Wow.
Okay.
monitoring, that kind of thing. So yeah, there's a lot of applications. So I used to work for a civil engineering firm, and we do view shed analysis. So if we want to put in, especially if it was like a business that wants to say, who could see me? You can say, I'm at this elevation. And they would say, okay, from all around here, who can we see? We use it now for water towers. And if somebody wants to put a radio antenna on a water tower, we can see, line of sight to see what kind of coverage that would have. So
That's cool.
there's a lot of different things that we can do with that. And it's right now, the new thing for GIS is going inside the buildings and actually having mapping inside the building. So that's kind of like the new thing. So
You mean like knowing where the plumbing is and everything?
Yeah, so they have building information systems, and then those are kind of morphing where you probably see Google Maps occasionally. If you'll see like the inside of a mall, and if you can have a tracking, you can actually see where you're at inside. So it's that more of on a like a company application rather than a public use thing like Google. But it's pretty smart. You have smart buildings, and you can know where you're at within the building. They use it we'll do LiDAR, there is light
Right.
ranging. We'll like do 3D modeling of the inside of the building. So you have a model, and then you could do scenarios for like fire and police if they want to do a simulated response, like where would we go?
Oh, wow.
And for us, it's nice because you measure it once and then you don't have to go out and measure it again. Okay, this is a 3-foot door and there's 18 feet between this tank.
Yeah.
It's pretty cool. So yeah.
Wow. You hear about technology and how it's improving things,
Right.
but until you get some details inside folks' jobs like yours, you don't really think about it.
Right.
And like what you were saying with Google Maps inside of buildings, I went to this San Diego Air and Space Museum. Turns out when you zoom in far enough on Google Maps, you can see the inside of the museum and drawings of all the planes and everything and where they are.
Wow.
Never even occurred to me to think of it in terms of the building's infrastructure.
Yeah. Yeah.
That just sounds fascinating. So how much is that being integrated into the systems, the water systems? Do you use it like occasionally, or is that pretty much what you guys are doing all the time now, is just continually adding the technology?
We're continually adding technology, and
Wow.
on utilities, like the kind of dividing line is a property line. So we are out in the public.
Okay.
Most of our stuff is out there. And then this would be something that our customer would do, a private customer, and behind their property line to do so. But we're using it on our facilities, like our water treatment plants, our pump stations, that kind of stuff. So things that we have inside that would be applied to soon.
Wow.
And then
Super cool.
Yeah.
it is really cool. But yeah, even like during design, they use these building information systems where it's basically 3D CAD of the whole building. You can actually rotate it, see what's going on, isolate different, I want to see all the plumbing systems. I want to see
That is so cool.
Oh my goodness.
and then that's kind
It's
of
not just in the movies anymore.
it's really a thing. That's been around for probably 15 years, the building information modeling, and it's pretty ubiquitous. So it's pretty cool stuff.
Wow.
Yeah.
I mean, that's so amazing because, those of us who, this is not the job that we do. So we aren't aware that there's this much technology that you can use. But I want to get to our question. So, because I think this is really cool. How does drinking water get to your house? So
yes.
This is a really important thing for all of us to understand. So can you go through the steps for us?
It depends on where you're at.
Okay.
Generally, water comes from two sources. Either comes from groundwater, like in a well, it's pumped, and then it's treated and distributed, or it comes from surface water. So it could be a lake, a river, the ocean sometimes, if you can have a desalination plant. But generally, it's surface water or groundwater. So most often, groundwater is very predictable. it's consistent. It's the same temperature generally when it gets pumped up.
Okay.
Gotcha.
The ground kind of acts as a giant filter before it gets to the well. So it's
Right.
clean by the time you get it.
Oh.
Surface water is very plentiful and it's already pumped up, so it's easier to get at. But it's highly variable as far as like the water quality and the temperature. So if you're on a river, you're pulling in water that it can vary from 35 degrees up to whatever in the summertime. So you have to worry about biology, what kind of things are growing there.
Yeah.
The groundwater, and you have to worry about that anywhere, but the groundwater, it's a little more predictable. So we have a mixed bag where the area that I cover between surface water and groundwater. So once it's brought up from those two sources, it's brought into a water treatment plant. And the treatment plants vary quite a bit, but generally there is settling. So it's basically initial settling of particles out of the water.
Right.
Then it moves over to filtration, which is more of a fine-tuned, think of if you have a at-home water filter that writ large,
Yes.
So we have, these filters are generally made out of multi-layer between like sand, anthracite, and sometimes we add granular carbon.
Right.
It's like you have a filter on your water system at home.
Mm-hmm.
Sometimes we do that on a large scale. So it goes through the filter. Filters usually last for about 2 or 3 days. We clean the filters, basically backwash it all, clean it, and then the particle size, the sand or the anthracite settles out first, then the sand, and then the carbon. So it actually goes back in the layers it's supposed to, based on the weight of the particle in the water.
Wow.
It's kind of cool, yeah. So after that, filtration, and then it's pretty much chemical addition. Disinfection is the next step.
Yes.
Disinfection it's usually chlorine. And then in the United States, a lot of places use gaseous chlorine, which is not super safe. Well, it's done safely, but it's not as safe as sodium hypochlorite, which is it's bleach. When you go to the store, bleach. That's a little safer to work with. People use that to disinfect, but we have a couple of installations around here where we use ultraviolet light as the disinfectant.
Oh, yeah. I've heard of that.
It inactivates viruses and kills bacteria. But usually that's a one-time shot. Usually you still have to add chlorine in. So when it goes out into the distribution system, there's some active disinfectant in there. So it lasts by the time it gets to your house or stays in the water tower for a while. But no, those are the kind of things that happen. Pump stations to get it to your house, water towers, all those things are part of the process that get clean water from the source to your tap. So yeah, that's kind of a general idea.
So I have always kind of wanted to know, with that, sort of backing it all the way up to where your water comes from, if you just envision a map of the United States, okay, here's America, we all live in different places in America. Is there a maximum distance that houses are allowed to be from a water source before, like, oh no, we need to pump water to this house from somewhere else because they're too far from this other source?
Absolutely. So during the engineering phase, 2 things are looked at. Elevations affect pressures. So that's one thing.
Sure.
And then there's friction loss in the pipe between the source and where it gets to your house. Generally, that's usually is pretty big diameter piping. So it's fairly low friction loss, not during just regular flow. Friction comes into play when there's a demand, like during a fire event. So people have a couple of fire hydrants open or fire full. That's where the pipe friction comes in a little bit more. But elevation is the big driver. So every 2.31 feet of height is 1 psi. So you 1 pound per square inch of pressure.
Wow.
Okay.
Yeah. So generally, these towers that you see, we shoot for 60 to 80 pounds per square inch psi.
Okay.
That's, it depends on where you're at. But generally, these towers are usually run between 160 and 200 feet tall.
Right.
Sometimes they're built on, the high part of town, so you can make a shorter tower. But that's what keeps the static pressure for the water in the system.
Never knew that.
Yeah,
Never knew the height of the tower was factored in.
Yeah.
That's cool.
Yeah. So that's kind of how it goes.
Okay, so I have a question because we're talking about water pressure. So, sometimes you'll go, and I know water pressure can be dependent upon like your shower head, right? Or, whatever, sometimes it's better and worse. But how does like water pressure affect it coming into your house? Because occasionally, I mean, I've been in a house and you turn it on and you're like, oh.
Yeah.
So what causes that to change?
Usually the pressure to the house, like on the outside, should be pretty solid. I mean, it should be pretty steady. So maybe it might, the height of the water in the tower up and down will vary a little bit, the pressure at the house. A lot of times there's constrictions on inside plumbing. Either it was undersized, or there can be sometimes plumbing over time will have buildup on the inside. So that actually the size of the pipe will constrict. Oh. You won't notice it on the outside, but if you see old plumbing, cut it open, you can see about half this, half.
Yeah, there's like corrosion or something inside it.
Probably something we don't like to talk about. It's kind of out of sight, out of mind, but that can stop the lower pressure. But a lot of times there's things that like your faucet, they have aerators, at the end of the faucet. Sometimes it's get plugged up, or they just get gummed up. You can replace those, and that'll actually help with the pressure as well. I think the pressure usually is there. It's just not getting to where it needs to, at least inside the home. So usually there's could be a filter, like a whole house filter that's needs to be replaced. Those kind of things are.
Okay. Yeah, because I'm not one who likes to turn on the shower and it just trickles, right? Like I like the blast.
Helps with the process, right?
Exactly. Okay, so I know this doesn't necessarily maybe fit in how the water gets there, but can you explain, because I've always wondered this, how does a hot water heater work? Because when you have multiple people in a house, right?
Oh, sure.
And then everybody wants to take a shower at once, and then you run out of hot water. Could you kind of talk about how that works?
Sure. So a hot water heater, usually, I don't know where it is in everybody's houses. There's two kinds. There's a tankless one and a tank water heater. So most people have a tanked water heater, and you buy them in different sizes. They're usually like 40 to 60 gallons. So and the inside, there is a heating element, and the heating element can either be electric or it can be gas. Basically, it keeps this 60 gallon or 50 gallon, whatever size you have, hot, even when you're not using it. There's a minimum temperature. When the water in there gets low enough, it reheats everything. And on your faucet, you usually have a supply. You've got a cold supply and a hot supply. Then you're balancing the sources between those two, and then it's basically hot water available. Now, the tankless ones are nice because it's hot water on demand. So water is actually a little more energy efficient. A lot of times they'll put the water heater right by the faucet. So you don't have a long time where you lose heat, but then you only heat what you need. But then you have to kind of beef up the electrical to get there to make sure you've got enough power to instantly make water hot. But no, those are the two options for on the water heater side of things.
So then why do you run out? Because I guess, is it only the water that's in the tank that's heated? So if you like the first two people get the showers in the morning, then the third person gets very little water?
That's 100% it. We have teenagers in our house.
Yes.
And I can verify that there's a benefit for getting in there early, right?
Oh, there you go.
Not fighting for hot water. But no, same boat. Basically, you've run out of water. And it takes a little while. The water heaters are not instantly heated, like the tanked ones.
Right.
Like the instantaneous ones. So it takes a little while for that water to get warmed back up. So yeah, that's what's going on there.
Okay. So far, all the houses I've lived in have had that water heater tank. I have wondered, is with newer construction and newer technologies and sort of that problem we were just discussing, are the tankless, is that where homes are going to go in the future?
I think so. I mean, it seems like a lot of new construction, and you see a lot more new technology like radiant heat is a little, rather than heat, all that kind of stuff. When the tankless water heaters came out, they were fairly expensive, so there was a little bit of a barrier to entry. But right now they're very affordable, and they take up a lot less space than a tankless water heater or a tanked water heater. So yeah, I think that's definitely going to be the way it goes in the future too.
Cool. Okay, so I have another question because we have someone in our family who has eczema. So, we're always been worried about hard water versus soft water. Can you explain the difference between what that is?
Basically, it's calcium carbonate in the water, and that's what drives the hardness. So depending upon where you're at, especially with groundwater, I lived in the Midwest. All of our water is hard. The good news is that it does seal up tiny cracks if you get the time, but the bad news is it does build up, can build up on the inside of the pipe. And it shows like at the end of your plumbing, like on a spigot or a shower, that kind of thing. But soft water, it has been, there's a couple of different ways. You can do lime softening. It removes the hardness. You can also do ion exchange, which is like reverse osmosis. And those kinds of things can remove that hardness out of the water, which makes it, they call it soft. But you'll notice it if you have never consumed like soft water and you've only drank hard water, you'll notice it when it's like, what is different here? So yeah less hardness in there. It's basically less calcium carbonate in the water. It can dry out. You notice you use more soap in the water. Like if you're in a place that has soft water, you're lathering up. That'll last longer. Hard water, so that because that soap is being consumed by the calcium carbonate in the water. So that's kind of why the soap lasts longer in a soft water situation. But
and what we do for the soft water, I mean, that's what the doctors told us to do to help, our child deal with the eczema. So we put in a filter in our house so that it, kind of goes through there. And it's funny too, because now that they have moved away and they come back and they're like, wow, the water feels like, it's more slippery or something because it's softer here.
It varies depending upon where you live at in the United States too. So hardness, at least in the Midwest, is for groundwater, a lot of it's limestone, like everything down like the bedrock, and it's all limestone. So that water, pulling it from a well, has been sitting in basically almost pure calcium carbonate the whole time. And that's where that hardness kind of comes from. It could be present in surface water as well. So.
Right. And what you were saying about how, depending on where you live in America, oh my gosh, the water is so different coming out of the tap in different places. Yes. I live in Colorado and I love it here. This is like the champagne of tap water. And when I go to my wife's family's house in small town, Ohio,
oh, sure.
me and the tap water do not get along. Like it has a weird smell, a weird taste. I just can't handle it. I have got to go to the bottle.
There's no judgment here. It's just a safe space. But no, I get, I think people get used, especially whatever they had during their childhood, that's what they get used to. And then someone else would come to your house like, oh, that's gross. I'm like, that's normal, right? So,
yes.
And then there's a bit of a local pride in however your water tastes. But yeah, it definitely varies quite a bit. When we travel, my family makes fun of me. Like we get to the hotel room and I turn the water on and go, oh, that's good water. It's like, no,
oh, that's good stuff.
Chicago has really good water. It's crazy. But then I went to Boston and it was okay. But I'm just saying.
I mean, and so in our house, they grew up with the water softener, but we also have a reverse osmosis tap, which we drink out of. Sure. So when we would go visit places, our kids would turn on the water and be like, can we drink this? Is this okay to drink? And I'm like, it's fine. It's just different, right? Yeah.
It's the same water that goes if you're going to go, fountain soda, whatever. It's the same water. It's
exactly.
all going in the same thing. So yeah.
The amount that goes into something that I am sure nearly all of us that aren't working in the water industry are taking for granted. We just turn on the tap and the water works. And if it doesn't, it's an immediate panic in the house of, honey, where's the plumber's number? We need help right now. The amount that goes into it, it really does become fascinating.
Yeah.
I don't necessarily want to do your job, but I want to ask you like 400 questions.
Well, and we appreciate your job.
Yes. Oh my gosh.
Definitely.
Oh my goodness. Yes. When people change their flags outside for like military appreciation or teacher appreciation day, where is the utilities appreciation?
Exactly.
My light switch works and the lights go on. Bam. The water every single time.
We appreciate that.
Yeah.
I am fascinated with the idea of the concept of just how much water there is on Earth, and I guess the noise out there in the world, talking heads on TV and stuff, that we might run out of drinking water here on Earth. So, and because we teach kids the water cycle and it keeps going through, is running out of clean drinking water something we need to be concerned about?
You know what? There are a lot smarter people than me that are working on that problem. But I will say, I was over 97% of the Earth's water is in the ocean.
Yes.
And so we have
a big percent.
Yeah, we have like groundwater is about 0.62% of the Earth's water.
Oh, wow.
Lakes, it's 0.09%. Rivers is 0.001%.
Oh my goodness.
Yeah, so like as far as the United States goes, I mean, and like we have the Great Lakes, which is an incredible gift, is something we need to conserve, and we need to make sure we use water wisely. But there are other options for getting the drinking water. So the company I work for, we have a desalination plant. I have not been involved with it, but those are starting to pop up. So you just have to figure out how it's a very expensive process to desalinate water.
That's what I've heard.
Can be very energy intensive, but also another option for getting water. So, but you're right. It's something to think about. We take it for granted. Everything's cool until it's not. And then we need to make sure that we make sure this resource is around for future generations.
And I would imagine, like everything else, there's technology that they're working on to develop to make the desalinization process less intensive and not so expensive and all these kinds of things. So, I mean, any of you kids out there that are listening, go into civil engineering and help solve this problem. That would be amazing.
There are a lot of you interested in water, so there's lots more you can keep learning about it.
I mean, that would be really, really cool, I think.
We're having a tough time finding people, actually, sometimes here in the last 3 or 4 years. So we need more people on the science and engineering side of things.
Right.
Maybe I don't know why they get scared away from it, but it's a great career and it's fun to do, and we need some help. So
okay, Trip's asking for help. As Galactic Space Geek Jeff, I think about all of this water talk that we're talking about here. When we are talking about going to the moon and starting a moon base, as well as pushing on to Mars, one of the very first topics that always gets brought up is how are we going to handle the water situation? So knowing how to get water, use water, recycle water, and conserve it is critical information, both for us here on Earth and pushing out into the solar system if we're able to do that.
Agreed.
Yeah, I think that's going to be one of the big things they're going to have to tackle. Okay, well, I have learned so much about water, but now I'm curious. Trip.
Oh, this is going to be good.
We ask all of our guests to give our listeners a challenge. What challenge do you have for them today?
Well, in the spirit of today's conversation, I challenge each and every one of your listeners to conserve water. And you're like, how do I do that? I just do baby steps. So the thing I started with is, you're brushing your teeth. Yes. And you leave the faucet on while you're brushing your teeth. There's no value in that. So what you're brushing your teeth, turn off the tap. And when you're done, turn the tap back on. Little things can add up to a lot of things. There's a lot of people on the planet. And if everybody did that, that's a lot of water that's saved. So just do little things, and you'll find other things that you can do that to conserve water around the house or at school or wherever you're at.
Yeah. Oh, I love that. So does that mean I can't take my, really, really long showers then?
That's, as we already talked about, Jen, that's not kind to the other humans in your house.
That's right.
Yeah. Well, there's only 2 of us now, so we're the teenagers are gone. But no, seriously, you're right. We should kind of be aware of all of that. Well, anyway, this has been so much fun. Again, I have learned so much about water. Thank you so much for being on Solve for Kids, Trip.
Thank you for having me. I really appreciate it.
Talking about water is absolutely a conversation. Like, we could talk to Trip and just keep on talking and talking and talking. And I feel like this is one of those conversations that, whether it's kids to adults, adults to kids, or all of us, we just need to keep this conversation going. Because there's so many facts, like 97% of the water on Earth is ocean water. Turns out, not yummy.
Yes.
I don't want that. Only 3% is that fresh water, and even that needs to be handled and taken care of before it becomes our drinking water.
Well, and the ocean water, yes, you can do a desalination process, but that's not cheap, unfortunately. So it's very important to keep fresh water available and flowing, and I thought it was really cool to learn how this works and the treatment plants and all of those amazing things. So Jeff, are you gonna go and conserve water and turn off the tap as you're brushing your teeth?
So here's the deal with that one. I do that all the time, but what I'm gonna do, just for my own visual, I am going to do this in reverse once. While I'm brushing my teeth, I am going to leave the water on with a giant bowl or one of my cooking pots to collect so that I can visualize and actually see how much water I would be losing every time if I didn't do that. And then I'm going to use that water to cook a pot of pasta.
Yeah, that sounds like a great idea. So you guys should all try that. And also maybe talk with your families or your friends. And what are some other ways that you can conserve water? Because this is a fantastic challenge. And of course, you can always share what you've learned or some tips with us. On our social media, we are at KidsSolve at Facebook, Instagram, and Twitter. And don't forget to check out our website, solveitforkids.com, where we have a page for every episode. So we'll have some more water tips on there. And also some books that you can read to learn more about water conservation and clean water and all those amazing things.
We really look forward to hearing how you guys are conserving water and what types of things. Maybe you'll come up with something we aren't doing and you can help us out. Until next time, you'll hear Jen and Jeff on Solve It for Kids.